viewers. This is Jedediah Educational Services Limited, and I think it's almost time for one of our classes. Let's go. Hi. So today we want to be looking at law of indices. Indices is the same thing as exponents. And we will need this knowledge. BODMAS, BEDMAS, PEGMAS. BODMAS simply means bracket of division, multiplication, addition, subtraction. And if you are not conversant with BODMAS, then we have BEDMAS. BEDMAS means bracket exponent. And that is what we are doing today. Exponent, division, multiplication, addition, subtraction. This is commonly in mathematics. In science, we use BEDMAS. P means parentheses, exponent, division, multiplication, addition, and subtraction. So, but whenever we use the word exponent, it's the same thing as index. So it depends on where you are and what you are used to. So today we'll be looking at some laws that is guiding us whenever you are to work with exponent or you have to work with indices. So let's look at this. 2 times 2 times 2 times 2. So if I need to write this into 10 places, I keep on writing up to 10. But don't you think there's a shorter way of writing this? Instead of repeating 2, 2, 2, 2, I can simply write 2 to the power of 3. 2 to the power of 3. And if you look at this, 2, which is the number to be multiplied repeatedly, these now serve as my base. And these serve as the exponent. And the all of these, that is my power. So let's look at some laws. The first law, which is the product law. What does it say? It says that when you multiply, what happened to the exponent? You add the exponent, so long they have the same base. And let's look at this example. 2 to the power of 4 multiplied by 2 to the power of 6. So the first thing you need to check is, do they have the same base? Yes, they do. 2, 2. So they have the same base. Just put one of the bases there. And what happened to the exponent? Add up the exponent. So we have 2 to the power of 10. And we'll leave our answer like this. This is an exponential form. Except if the question says, write it in standard form. That's when you cannot find out what is 2 into 10 places. What will be? Otherwise, leave your answer in exponential form. And that is the first law. Now, let's look at the second law, which is the quotient law. What does it say? It says, when you divide, what happened to the powers? What happened to the exponent? You subtract the exponent. So let's look at this. 3 to the power of 4 divided by 3 to the power of 3. So the first thing you need to look at, do they have the same base? Yes, they do. 3, 3. So we pick the base. And what happened to the exponent? We subtract 4 minus 3. And that gives us 3 to the power of 1. And another law, it says, when you raise a number to the power of 1, what happened? It's the same thing. 2 to the power of 1 is 2. 1,000 to the power of 1 will still give you 1,000. And what happened when a number is actually raised to 0? 5 to the power of 0. That gives me 1. So which means any number to the power of 0 is 1. 1,000 to the power of 0 is 1. 35 to the power of 0 is 1. 56 to the power of 0 is 1. You may want to ask yourself, why do I need this? Or where will I need this in the real world? Let's look at it. You may now ask yourself, why do you think these laws are important in real life? Or where will you use it? These laws are actually good when it comes to simplifying complex calculations. Instead of writing 1 million, 20 million, you can easily write 10 to the power of 6. And when you do this, it makes equation clearer and easier to work with. And also, your work will not actually scare some people when they see a lot of zeros, a lot of figures. Some people get scared with it. But when you use the law of indices, when you apply it, 1 million, you can easily have 10 to the power of 6. And also the science and the engineering, they use it a lot because they deal with quantities that often extremely large or tiny. And also, for example, the distance from Earth to a star might be 9.46 times 10 to the power of 12. Then you can imagine if the exponent is not there, how do I write 10 to the power of 12 kilometers? That would be too long, so many zeros, and that scares a lot of people away. Also, when you look at the area of finance, to calculate the interest, if money grows at 5% per year, definitely the formula involves exponent. So exponent really help a lot of people, not only in mathematics. And finally, problem solving and logical thinking. Learning and applying the law of indices build algebraic thinking and help students recognize pattern, because you see the pattern your work is actually following. That is it for today. So till I come your way next time, my name is T. Elizabeth, your mathematics teacher. See you soon.